All right, today we're going to go over the flip-flop. Flip-flops are really, really easy. It's a set reset flip-flop, so let's take a look at one. Here's a diagram of a set reset flip-flop. Two transistors, they're crossed, so this one can turn on this one and this one can turn on this one, but only one can be on at a time. If this one is on, then this pulls down and this transistor's off, and then this will conduct and it'll turn this transistor on, and then vice versa. So you can do the set reset by grounding this base, turning this transistor off, and the other one will turn on, or grounding this one, this will turn off, and the other one will turn on. So let's give it a try. Here it is. Can people see the LED there? I think so. Yeah, I think you can see the LED. Anyway, so I have a little ground here. If I ground one, it flops over. If I ground this one, it flops over there. Flip, flop, flip, flop. So all I'm doing is grounding the base, grounding the base, grounding the base, grounding the base. Now, is there another way that we could operate a flip-flop? All right, let's think about it. All right, so here we ground the base, that turns this off. Ground this base, that turns this off. What if we forcibly turn this one on? Let's say he's off. Let's see if we forcibly turn this one on, okay? Let's see if we can do that. All right, so here we go. We turned it off, and now we're coming here, we forcibly turn it on. Forcibly turn it off. This is positive. Forcibly turn it on, okay? So we can do the set reset either by grounding this one and grounding that one, or grounding this one, or pulling it up, okay? So you can imagine this is a switch too. So you can switch it, pull this guy down temporarily, it'll flop, or you can switch it, turn this guy temporarily on, and it'll switch it. So remember that. You don't have to do the ground. You can do the ground and then up, down, up, down, up, and it'll still toggle back and forth, okay? Because that's the way that the flip-flop here works, all right? So let's get a drawing of that because it's complicated. All right, this is the reset, the set reset flip-flop in the 555. And it's very complicated, and especially the way it's drawn, it's very complicated. So I'm first going to point out a couple things, and I'm going to try to simplify it. First is that there's some current sources at the top, okay? These are current mirrors, but they're just used as current sources. So this particular one, you can see, has wired like a diode, and this 15K resistor sets the current in this leg, and it's just mirrored over here. So it's just a way so that we can create two current sources. It actually goes over to the other comparator. Remember this one? That comes over, and actually that's part of a current source too. So these two things go together as a current source, so that one diode transistor sets the current, it gets mirrored into that one, it also gets mirrored into this one, so it's used, that current is used three different ways, and so that creates a current source in this. And one thing I didn't mention is you also get a collector on this current source. You get a high impedance here, so you also get a lot of gain out of these because of this high impedance current source. Okay, so let's go back to the flip-flop. So yeah, so this is just current sources, okay? And then we have a whole bunch of, we have 4 transistors here, but let's just consider 2 of them to begin with, okay? 2 of them are wired like this, all right? So we have the current sources. One current source is going through this side, and one current source is going through this side. And these guys are just going to toggle back and forth. Now you notice there's no resistor on this one. And I guess that's okay because we have a current source and we can't drive too much, and we have a resistor here as well. So you can't drive too much into here. I guess it just saved the guy from having put in an extra resistor. I don't think it would hurt to have a resistor here, but it is a push-pull type thing, right? And I mean a flip-flop type thing. All right, so how do we set and reset a flip-flop? Well, we need to have a let's draw on some values here. This one's 4.7. Oops, 4.7K, and this one is 15K. Doesn't really matter, but just to be smearing. This is 4.7. 4.7K. There we go. All right. So remember we had a way to pull down on one and then pull down on the other to do the flip. And I told you this one does the pull down on one and then pull up on one. So we're going to have it here. We're going to have pull down, and we don't have a switch, so we're just going to use a transistor, okay? All right, so there we go. We have a way of setting it at least to one state, okay? So that's going to go off, all right? And where does that go? That goes to one of the comparators. So one of the comparators flips it to this state, okay? And then we need to flip it to the other state. And we could do the same thing here. We could have a transistor and then flip it the other way around, but that's not the way it's being done. The way it's being done is it also connects to this node, okay? And there is a current source over here that can be turned on and off. And that current source can come in and turn this node on. So this is one way to turn it off. This is one way to turn it off. And then it just flips back and forth. So there we go. Q16, Q17, and this one is Q15. Okay? So Q15 is here. It can grab Q16, Q7. So these are the two guys that toggle back and forth, okay? Now there's an extra thing in here called Q18. And look he's just wired like a diode, okay? So he actually sits right here, okay? So there's a diode right there, okay? And don't ask me right now why that diode is in there, but it will become clear when we talk about reset. So we have a diode in here. It doesn't really do much to the circuit if it doesn't help with the understanding. So I've drawn it in kind of small here so you ignore it. So anyway, there is a diode there, okay? And that one is Q18. All right. So the current sources are Q19A and B, okay? So why is it called 19A and B? Everything else is numbered. In the actual 555, okay, the PNPs that are used are called lateral PNPs. They conduct laterally on the substrate instead of up and down. They conduct side to side. And this transistor here actually looks like this. There's actually two collectors. So this is one transistor, okay? This is Q19. So Q19 has one emitter and two collectors, okay? And if you think about this, it's basically current sharing. Current comes in and then current goes out two different ways, equally. And so it's like this device. It's a current mirror, because whatever current is set up in here, the current is the same in these two emitters, or two collectors, okay? So this is what was in the original part, Q19. They replaced it with two separate transistors that does the same function. So they called it Q19A and Q19B to make sure that the numbers of Qs add up to the correct number. So that's what's going on here, okay? So we have Q19, 16, 15, 16, 17, 19, 18. There we go. We got them all, right? 1, 2, 3, 4, 5, and 6, okay? 1, 2, 3, 4, 5, 6. So we've got everything accounted for here. Okay, so let's take a look at a couple things here. We have one of our comparators comes in and one of our comparators come in. So here's where one comparator comes in, and here's where the other comparator comes in. It either sets or resets, okay? We have an output, flip-flop output, okay? That comes off of right here. comes off of Q17, right? So this is the out. Oops. Out. I can't draw today, can I? Out. All right, out. Thinking about other things while doing a video. It's not always good. All right, so we have flip-flop out, and you can see that it's push-pull, right? This guy is either on or this guy is on. And this guy is a current source, okay? And so it's a current source up, or it's just grounded out. So it's kind of a funny output. So we have one more signal here. It's called reset signal, okay? We have the reset signal. So we remember on our master thing here, the flip-flop can also be set externally with a reset signal. It's actually low true, and not reset. And so let's take a look at how that function works. It's right here, okay? It's actually not reset. And it reaches in here, and this here, okay, there's a current source and it's coming down and it's supplying a current to this thing, right? And right here, okay, just before the diode, so that's why the diode is in here. Just before the diode is reset. Not reset. So what you're doing is you're cheating the current over to reset. So instead of it coming into this thing and allowing it to turn this guy on, okay, it will not allow this guy to get turned on because it's stealing all of the current. It's basically negating this, and then this current will turn this guy on, right? So yeah, so not reset is a way to jump in and force this thing to a particular state. So that's how reset works. It's just a wire. And it explains why you have to have this little diode in here, so that negative voltage doesn't sneak through and mess everything else up. It's kind of isolated. So that's why the diode is in here, and that's how the reset signal works. All right, so that explains everything about the 555 flip-flop. And the only other thing we really have to worry about is the output stage.